Imagine two children sitting down to share a bag of gummy bears. Now, they both love the red ones, but the bag? It's a rainbow mix of 5 different colors. To keep things fair, they agree to a simple rule. Close your eyes and pick 10 gummy bears at random, one at a time. Sounds foolproof, right? The first child dives in and starts picking. Here's what they pull out. Red, 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 yellow, yellow. Huh. That's a lot of red gummy bears. Now this could be just an incredible streak of luck, but something feels fishy. The second child raises an eyebrow. Are you peeking? They ask. In this scenario, 2 things make it suspicious. The distribution of gummy bears. It's unlikely that he randomly picked so many red ones. And the order in which he picked them. All reds in a row. Existing work suggests that children's judgments are often influenced by whether outcomes deviate from what is expected by chance, and that they may also see ordered outcomes as unlikely to occur purely by chance. But can they recognize cheating by making these assessments? We wanted to explore this question in our paper in developmental science titled Who Peaked? Children Infer the Likely Cause of Improbable Success. We did this by conducting 4 experiments. In the first experiment, we tested 80 4 to 7-year-olds, mostly in person at their childcare centers and schools, with the remaining remotely over Zoom. After confirming that the child understood which gumballs were yucky and which were yummy, each child completed 4 trials in which they viewed a blindfolded character pick out 10 gumballs from a bowl. The bowls in each trial had the same distribution of gumballs, but in 2 trials, the outcome was suspiciously good, and in the other 2 trials, the outcome was as expected. At the end of each trial, the children were asked if the character peeked or remained blindfolded to test whether they thought the character knew which gumballs they chose and had cheated. The 3 remaining experiments were similar, but we manipulated variables such as the ratio of yucky to yummy gumballs in the retrieved outcome, the ordering of the outcome, and the ratio of yucky to yummy gumballs in the bowl. What we found was that by age 5, children are more suspicious of improbably good outcomes, more suspicious of ordered outcomes than disordered ones, and use both these cues to infer cheating. Not only do these findings show that young children can detect cheaters by using statistical reasoning, but they also show that children's theory of mind reasoning is flexible and not based on rigid rules like seeing leads to knowing and success, and not seeing leads to ignorance and failure. If children were limited to seeing things that way, they would have to conclude that every character peaked, since each one retrieved some yummy gumballs. But this didn't happen. In the 4th experiment, for example, children's judgments about peaking varied despite identical outcomes, depending on the bowl from which the gumballs were drawn. This would require children to consider the distribution of gumballs available and the odds of getting them, reflecting a sophisticated and flexible integration of theory of mind and probabilistic thinking. To learn more about this topic and to delve deeper into the methods and other implications of this research, check out our full paper in developmental science or reach out to us by email.